Nyquist, I told you, so it should be accordingly. I hope that everything is fine. Now, anybody got any question? Because we have another 4 minutes to go. If anybody got any question, then maybe I can entertain now. Yes, sir. Anybody can raise your hand and can talk. Yeah. Khandakar Sami, you can lower your hand if you have no question. Okay, good. Now, any
Sir, problem related to sir,
hey, who is the guy?
Sir, Khandakar Samil.
Okay, you Samil, go ahead.
Sir, problem related কি কোনো question করা যাবে sir?
Come again? During the exam time?
No, sir. Right now, sir.
Oh, yes. You can ask me any question, except, oh, sir, what question coming in the exam? Yeah, go ahead.
Sir, last যে প্রবলেম স্যার হাফ করানো হয়েছিল স্যার ওইটার একটা প্রবলেম ছিল, সেটা হচ্ছে যে আমাদের ধরেন স্যার যখন ওমেগা ইজ ইকুয়াল টু 0 we are find something and omega is equal to infinity we find something,
right,
angle. But আমরা যখন স্যার GH এর অ্যাঙ্গেলটা নিচ্ছি তখন স্যার অলরেডি সবসময় স্যার -180 থেকে কাউন্ট করতেছে, এটা কারণ কি?
Okay, because this is the actually this is the gain phase crossing point. At a phase crossing point is by definition it is from -180 degree. -180 degree is a baseline for the phase angle, and for the gain the baseline is 1, magnitude was 1, which is 0 dB gain. That's what next class when you go for Bode plot you'll come to know about these things also. And -180 degree we are taking it because the origin -01 point is located on the -180 degree line, right?
Yes, sir.
Yeah,
yes,
this is the main reason actually. So the magnitude is 1, right? -180 degree magnitude is 1, and phase angle is 180 degree line. So magnitude phase angle baseline is 180 degree minus 180 degree, and magnitude is 1, and if you take 20 log of 1 is 0 dB. So either 0 dB or 1 is considered as the gain, and phase is -180 degree as a base, so that you can go for your gain margin, phase margin based on this. That one you'll learn from Bode plot and it will become much more clear. Hopefully I don't make trouble with this, but how to calculate these things, do you know that or not?
Yes, sir, I know that, sir.
That is very
yeah. Like I'm not Nichilan cannot say that, so just
that's okay, fine, no problem. That's okay. This is not supposed to be the question now, because here today there will be no explanation question coming that describe these things, define that thing. All today you have to prepare for the problem, how to solve the problem. That's what the problem I have solved the last few days and given you the practice problem. Do you have any question regarding the problems?
No, sir. No, sir.
Good. Then you are clear. Any other got? Any other people got any other? Last 1 minute. I think it should be fine. We are closing the question answer session. No, not now. We can discuss it later. Okay. For the time being, we are now jumping to the exam question. Let us go with that. Okay. Now let's come back to the point. We are stopping sharing these things. Now all of you be ready. Oh no, sorry, according to my computer time is 28, 2 minutes to go. Okay, I think I'm preparing it, but all of you listen carefully. I'm going to send the question paper by email to you also, so you can open your email and you can get it, remember. And question paper you can get it by email, and that is the way you have to reply me. So I think everybody should be okay in that case. I'm very much wondered if anybody missed the exam, absolutely straight away he will get 0. Cannot say, sir, I will sit for exam for the next section. No, I can, even if I consider cut marks from there. So everybody, I mean, section 1 should be with section 1, section 2 students should be with section 2 students. Then you can get maximum marks. Otherwise, action will be taken accordingly. Okay, so you can just ask your friend, those who are thinking like that, to sit with other groups. Will not be considered at all, I'm telling you. So careful about it. Okay, now we are having last 1 minute. Yep, 29. So we are going to start within 1 minute time. So everybody again get ready with these things. And I'm telling you again, please don't try to, as I cannot tell you, don't try to do any mishap. Don't try to copy from each other. Don't try to do any mistake. a wrongdoing thing, as I always tell you from the beginning. So everybody should be careful, be honest, then you can success in your life. All right, I wish you good luck. I hope that I'm going to show you the question paper, sharing these things, and you can start, because last 1 minute we are having just 1 minute to go. Okay, so I'm going to show you the question. Yep, you can start now. I have already sent the email, so you can see the email also. Go ahead, start first, just 12:30. And also it is in the BUX, so BUX also uploaded. Yes, what's wrong?
Sir, we
What?
can't see the questions around the
Okay, okay, you get a snapshot. I sent by email and it's on the BUX. Can you see now? Can you see the question paper?
Yes, sir.
Yes, sir.
Okay, go ahead. One of you have dropped down. I'm very much wondered. Okay, I'm just getting the snapshot of this thing. Just a minute. Abdul Kabir. Okay. Please don't go outside the classroom. One of you drop down and come back. Please don't do that.
Should we use the graph paper?
Sir, do you have to use polar plot or just we can draw in the paper? Hello?
I'm sorry, can you repeat slowly?
Do you have to use the polar graph paper or we can?
No. Polar graph paper is not required at all. It is sketching.
Okay, sir.
You see, this is sketch, the Nyquist is sketching. So no need.
Sir, can you hear me? Hello, sir.
Hello? Hello? Sir? এক্সাম টাইম কি শেষ না নাকি? হ্যালো?
Okay, hello. Time is over. If you're late, 1 minute cut, remember. Okay, I'm calling your name,
Sir,
those who submitted. Yeah, go ahead.
sir, I sent the mail, sir. Can you please check?
Yeah, I'm calling your name. All of you listen. If you're late, 1 minute late, 1 mark cut. I told you already. Okay, now listen. Shubho, DJ Shubho, DJ Shubho, I received your one. Hasibul Hassan Siam, I received your one. Adnan Islam received. Aniruddha Barman received. Rakin Yusuf, I have received your one. Muhammad Saiful Haq received. Then Sharif Ahmed received. Then Atikur Rahman received. Alamin Patwari received. Now I'm telling you, you can check your computer. 1 minute
Hello?
late, 1 mark's gone. Yes, sir. Go ahead.
স্যার কতবার সামিল
Samuel Sakib, I received. Rifat Ahmed, I received. Yep. What is this? Yeah. Now go back again. Patwari, Rafi Khan received. Muhammad Abdul Samad Bhuya, I received your one. Then Muhammadul Kabir Pial received. Okay. Those who are not submitting, your marks will cut automatically. Careful. 1 minute late means 1 marks cut. At least you should understand, you should not waste time. Okay, Fairuz Binte Farooq, I received your one. All right. Okay, then Rahatul Jannat, received 1. Aditya Das received. Okay, Tawfiqul Islam, I received. Maimuna Pranti, I received your one. Yes, sir. What happened? Hello, go ahead.
Sir, I have sent you. It's Shafi Manjur Khan.
What's your name?
So Shafi Manjur Khan.
Okay, so somehow you have to send it back and then come back to the class. Manage it.
Sir, I
Hello?
have sent it in a separate email. I am now
Yeah,
sending
what is
you.
your name? Rabbul Khan, I received. And Sadia
Sir,
Sabah.
I have said.
Yeah, Sadia Sabah received. Shafi Manjur Khan, I received. And
Sir, Sumaya Majed.
yeah, Sumaya Majid Shwa, I received. Then Jaharat Tabassum received.
Yes, sir.
Then go next. Okay, Mahbub Sifat received. Aditya Dash, I
Didar
told you
Alam
already.
Siddiqui.
Yeah, Mahbub Rifat I got. And then
Didar Alam Siddiqui. sir.
Didar, yeah, that's right. Just received, I think. Let me check. Yeah, Didar Alam, I received your one.
Sir, I send it. Sir, Numan.
What is that? Numan.
Sir, Numan, yes, sir.
Oh, you send it to me, the reply email, this announcement reply email. I have sent the question to you. And why you are sending me the announcement one? I'm very much wondered about your foolishness, all of you. Okay, I just don't know why you are doing like that. I think let's go for it. Jaharat Tabassum, I got it. Rokon Jaman, I received Rokon Jaman's one. Saud Noman, I received
Sir.
Saud Noman's one.
Thank you, sir. So confident.
And I hope that most of you already got the name. Okay, Didar also send the thing to there. No problem. Wherever you send it. Don't send it again. And yeah, any other people left, or all of you already got the name? Anyone left? Mahabub Sifat. One thing I'm telling you, you delayed by 1 minute means 1 mark should be cut. Remember, some of you sent it at 12:56. That means his 6 marks will be cut.
I have sent already.
Yeah, I know. It's already recorded. So don't worry about it. You delayed means you are losing marks.
Sir, maybe net connection was.
Come on. Then my mobile is there. You should call me and tell me the problem if you have. But when you send it, then and then it will be recorded the time, remember. So that time I'm going to tell. Anybody have any problem to send? Just tell me now. Okay. Or call me at my mobile. I think otherwise I can't.
Sir, I'm Rabul Khan, sir.
Rabul Khan, I received your one, so you don't need to worry about.
Sir, could you check if you have received 3 pages or 2 pages? Because in my sent it is showing that a sentence, page number 2 is not being sent.
Just a minute. Okay. Okay, I received 2 pages, but don't try to misguide me. 3 page means you fill the 3rd page after the time, right?
No, sir, the 2nd page is missing. Page 1 and page 3 have been sent.
Okay, then send the 2nd page, bit faster.
Okay, sir.
With the same thread. Okay, any
Okay,
other
sir.
got any question? I'll check it, remember. Everybody submitted already? Hey, anybody left or it's already submitted, everybody? Didar send it
Sir,
once.
I have sent you the mail.
Yeah, I got it, but this 24, 5, 6, 7, 8, 9, 9, and 10, 13. Still three script left. I don't know. Anyway, I'm not worried about because it will be coming in time. So I hope that everybody had submitted in time, and I appreciate that thing. And I'm going to take it as it is. Okay, fine, no problem. The exam time is over. Now we are going to start the class. And before starting the class, yeah, go ahead.
Rabbul Khan, sir. Sir, I've sent the
It's
center
all right.
page
Send
2.
it. I'll get it definitely, no problem. But any other
Okay.
issues? Otherwise, I'm just jumping to the class now. Okay. Now, if you go with this, remember, I'm just telling you. Just hang on. I'm going to take the snapshot of the attendance again, and I'll see how many of you. Two of you left the classroom without any reason. You'll be in real trouble. One of you called me over the phone that you have some problem with the network. Rest of the people do not have any problem. I don't know how they left the one student left the classroom. I'm going to get the snapshot. Just 1 minute. Don't leave the classroom. I'm getting the attendance now. Please don't move. And the guy who left, he will be in trouble. Okay, then one more shot. Okay, good. Now 31, that's when one student without notice left the classroom. He'll be in real trouble. Okay, now let's come back to the point. We are going to start the class now without wasting time. Just before starting class, I would like to give you 2 to 3 minutes time for refreshing your brain. And after that, we are going to start the class. Okay, so can you see the screen? Hello, can you see the screen?
Yes, sir.
Yes, sir.
Yes, sir.
So today we are going to talk about the Bode plot, but I'll after 2 to 3 minutes time, after refreshing your brain, then we'll go for that thing. But before we go for refreshing the brain, I'd like to what do you call that? Just a minute. Okay. Can you see the thing?
Yes,
Sir,
sir.
video.
Yeah.
Yes, sir.
Can you hear the sound?
Sir,
No.
No,
sound.
sir.
No, sir.
No, sir.
Okay, so
Sound.
just read the Bangla thing.
Okay, okay.
Okay, I think that should be fine. What I just a minute. Uh, okay, so this is one of the 201. Those who had done with me 201, I think you know that I was talking about the human quality development, and over there, a couple of things I used to tell. And one of the human quality development attributes was obey your parents. Remember? I think some of you did the HQD with me. Can you hear me?
Yes, sir.
Yes, sir.
Yes, sir.
Forgot it already. So this is one of the thing actually I'd like to share with you. That's what I told you, and this is the example actually I just remind you. So just keep in your head that this is very important attributes to obey your parents. The world is moving in such a wrong direction. All of you have to take care. Otherwise, we all will go into the wrong direction. So become real human being instead of animal. So have to, the bottom line is have to take care of your parents, obey your parents and listen what they are saying, and follow these things, because one day you will be parents and your children will be follow suit. So everybody should be careful about it. Okay, so I think we have enough time already gone to refresh our brain. Now I think we can come back to our study. And today's topic, as I told you, we are going to learn about Bode plots. And for the Bode plot, we need the Semilog graph paper. And I hope that all of you are having the Semilog graph paper with you. So first of all, we have to do some sort of calculations. And after that, we are going to plot it on the Semilog graph paper. This is another frequency domain analysis method. So we are going to learn. So what I'm doing for that reason, I'm going to pick the same example so that it will be easy for everybody to understand. The same example means last time I have taken the example of an uh, open loop system, open loop transfer function. So the same transfer function I'm going to take so that it will be easy to understand. The open loop transfer function is giving us the system characteristics and performance, and that's why we are going to take all the time the open loop transfer function, which is nothing but GH, as you know. So this time we can pick an example of the open loop transfer function as the, for example, we are getting 2 divided by S into S plus 1, S plus 2, like that example, so that every time it will be easy for you. That's why the same example I'm taking, S plus 1, not 2. So If you take that example s plus 1, s plus 2, then the Bode plot, you have to go for this sample. And what is Bode plot? If we want to see that Bode plot is, by definition, actually the Bode plot is combining of two things. One is your log magnitude curve, and another one is a phase angle curve. So the phase angle curve and the log magnitude curve, what are they? The log magnitude curve is actually, the log magnitude curve is defined as thus dB versus omega. And the phase angle curve, which you already know, phase angle curve is defined as a degree versus omega. So these are the two curve actually we have to draw today as a Bode plot, and the combining them together on the semi-log graph paper gives you the Bode diagram. And after getting the Bode diagram, then we have to apply the frequency domain method on it and find the system parameters. So this is what our main target today. So we are going to take this is as an example, and from here what we are going to do is we have to find from here, from this equation, we have to find the log magnitude equation, because log magnitude curve should be drawn from the log magnitude equation. And also we have to go for the phase angle equation. The phase angle equation we have to get in order to draw the phase angle curve. So this, from this example, we are going to find these two equations, and then we have to calculate those two equations points, and then we'll start plotting it on the semi-log graph paper. So I appreciate if everybody take the semi-log graph paper in front of you. I'll appreciate it. Now let's come back to the point. If you get that example that GH equal to 2 divided by S into S plus 1, S plus 2, S plus 2, then as we know, you can find the value for that one as 2 divided by omega root over 1 plus omega square, 4 plus omega square, and I have tangent inverse, as you know, that minus 90 minus tan inverse omega minus tan inverse omega by 2. So this is what the phase angle we have found last time. That is the thing. Now the log magnitude equation will be log magnitude equation. If you want to write from here, then it will be coming from the value here, which is GH magnitude. So dB will be equal to 20 log of dB means log of GH magnitude you are going to go, and that gives you nothing but you can easily understand it should give you 20 log of 2 minus 20 log of omega minus 20 log of root over 1 plus omega square minus 20 log of root over 4 plus omega square. So this is what the log magnitude equation, and the phase angle equation is as it is. You have already got the equation that is straightforward because degree. So this is your phase angle equation, DH phase angle equation. So your GH phase angle equation is coming as a degree. So you can write here that a degree equal to GH magnitude, GH phase angle, which is nothing but minus 90 tan inverse omega minus minus tan inverse omega by 2. So this is what the phase angle equation, and this is the log magnitude equation. From this you can get the phase angle equation and log magnitude equation. You can get it from there straight away. I think you understand how I got it, because log A by B, A minus B, then A, B, C, A minus C. Like that way you can expand it and you can get this dB versus omega and dB versus. So you can see in having here dB versus omega. Omega is here, omega is here, omega is here. These equations are dB versus omega, and the degree versus omega. Degree versus omega also you can easily understand degree, and this is omega omega. So this equation can give you these two curves, and those two curves we have to plot next. I hope that everybody understood the log magnitude equation to write and phase angle equation to write from the open loop transfer function. Everybody clear?
Yes, sir.
Yes, sir.
Good. Now, if we want to go for plotting these things on the graph paper, then we have to do the calculation for the graph. One is an omega at dV and degree. If you take the graph, a chart like this, then what will be the frequency you are going to consider to calculate the dB and degree? Like equation for dB and degree we have already seen. This is the dB equation, this is the degree equation you already got. So from these two equations you can calculate for different omega. Like last time, you are not going to do that omega equal to 0 to infinity, all the omega calculation. For Bode plot, very much particular, you have to find the corner frequencies to calculate the dB and angle. So if you go for corner frequency, the corner frequencies are what? Corner frequency. Corner frequencies are what? So you have to find the corner frequencies from the pole and 0. But from here, there is no corner frequency because there's no zeros. I'm just going to show you here, then you can get it. Let's say if you have a GH equal to like this, let's say K into 1 plus T1S, 1 plus T2S, and then you are getting here S square, 1 plus T3S, 1 plus T4S, just example, 1 plus T5S, like that. Then how many corner frequencies are here? How many corner frequencies are here? Okay, first question, how many corner frequencies are here? Altogether there are 5 corner frequencies. Corner frequencies. How come? Corner frequency 5, that one corner frequency coming from here, one corner frequency from here, one here, one here, one here. These are the 5 corner frequencies we are getting from these 5 terms, from the 2 zeros and 1 pole. So from here, what do you get? The corner frequency omega C1 will be 1 by the time constant T1. So 1 by T1 is the corner frequency. And from here, the omega C2 second corner frequency will be from here will be 1 by T2. And from here, this corner frequency, let's say omega C3, you can say is 1 by T3. This will be omega C, corner frequency will be here 1 by T4. This will be omega C5. The corner frequency will be 1 by T5. So this way the corner frequency should be calculated from the transfer function. If you follow that, then what will be the corner frequency coming in our case over here? Can anybody tell me how many corner frequencies? First thing, think about it. How many corner frequencies are there? Hi, Dax.
2.
How many?
2.
2 corner frequencies. Good. One corner frequency is coming from here. Another corner frequency is coming from here. So you can say this is omega C1 and this is omega C2. These 2 corner frequency you can consider. Now, if you consider omega C1, then omega C1 will be what? Can you tell me?
So 1 by 1 and 1.
1 by 1 is 1, right? That's radian per second. And omega C2?
So 1 half, 0.5, sir. 1 by 2.
Hey, rest of you are dumb. 30 students there. I think again one duck already left. Okay, I'm just hold on. I'm going to catch that duck without any Mahmoudul Kabir. Just a minute. I'm going to take another snapshot. Catch this duck. Why without notice? Just left the classroom. Okay, now let's come back to the point. Omega C2 equal to what? Anybody?
Radian per second.
Huh? Okay, I'm just going to tell you, if you compare it with this, let's say, that one was like this, as a 2 divided by S into S plus 1, S plus 2, let's say here. So 2 you take out, then 2 you get S, 2 by 2 is 1, and then you know 1 by S, and this is 1 plus 0.5 S, like that. You can just imagine like this, right? You take out 2. What?
Omega C2 is equal to 2 radian per second.
2 radian per second. But what you said, 0.5, right? 1 by 1 is 1. You said this thing is okay. Another one is this one, which is omega C2 is 1 divided by 0.5 means 2 radian per second. What you said is wrong. So finally, directly you can get this 2 and 1 are the corner frequencies, or you compare it with this one, same thing. So corner frequency, there are two corner frequency, one corner frequency is 1, another is 2. Hey, all of you understand it? Look at it. And do you get it?
No, sir.
Yes? Shall I
No,
proceed?
sir.
What? No, sir. Any
Sir.
question?
Yes, sir. I cannot understand.
Okay, good. What is your problem? This part you understand?
Yes, sir.
Okay, can you compare this one with that? No, sir, I have no brain to do it. Is it like that?
Yes, sir.
Oh, yes, sir. What do you mean by yes, sir? This is S, right? It is S,
Yes,
not
sir,
5. Yeah.
Oh, okay, sir. Then I understand. Yes, sir. I can.
I should shoot you. Are you
Now, sir,
kidding?
it's okay.
What? Then you understand.
No, sir. I just think that how this come.
5. Oh no, there is no 5 here. It should be S actually. 1 plus S. I have taken it. And if you take out 2 from here, then 2 by 2 is cancel out 1, right? These 2 I have taken out. Then what will be this? This will be 1 plus 0.5. Oh, you cannot understand this. You are, what are you telling? I'm very much wondered about these things. I think this is very simple job. Look, 2 divided by S into S plus 1, S plus 2. I have rearranged it in that way. 2 I have written, S I have written, then S plus 1 I am writing 1 plus S. Hey, S plus 1 can be written 1 plus S. Why are you confused?
Now, sir, I have.
Okay, now listen, I understand. Now this 2 you take out. Then what will be this? This will be 0.5S plus 1. Can I write it?
Yes, sir.
That is what I did actually. And then these 2 to cancel can be cancelled. And then what is the remaining thing? I'm writing here 1 divided by S into 1 plus S, 1 plus 0.5S. That is what I have written. And from here we got, this is giving you omega C1 equal to 1 by 1 is 1. And this is giving you omega C2 is equal to what? 1 divided by T1. T1 is 0.5 here. 0.5 is 2 radian per second. Now you understand it. Hey.
Sir.
So why
Yes, sir.
are you killing time so that everybody become annoyed and kill you? Okay, let's come back to the point. All your friends are annoyed because how come you cannot get it? Now you should be okay. Are you okay? Look at it. Don't worry. You have. I'm not going to tell you anything because I'm just wondered about how come so simple thing. But you just check. I hope that everybody should understood by this time. You're third level student. You should understand this sort of calculation. Okay. Now look, 2 radian per second, and this is 1 radian. These are the 2 corner frequencies we are having in our example. And for calculation, we have to consider these 2 corner frequency. Omega C1 is equal to 1 radian per second. Another one is omega C2 equal to 2 radian per second. Finish your job. Now you have to calculate this for these 2 frequency, not like last time, 0 to infinity, 1000 points you have to calculate during the polar time. But in Bode plot time, only these 2 enough. These 2 corner frequency you have to consider because there are 2 corner frequency from our example. But 2 more frequency you have to consider along with this, like last time, omega to 0, omega to infinity, minimum, maximum. That type of thing here also you have to consider. So one frequency you have to consider is omega I, the initial. Another one you can say as omega F, final value. These 2 initial and final frequency you have to consider, like omega to 0, omega to infinity, like that way. But here you cannot go for omega 0 and infinity, then it will be hang because the semi-log graph paper you cannot plot it. Okay, so what frequency omega I and omega F you have to consider here in case of Bode plot semi-log graph paper? You have to consider the omega I will be in such a way so that omega I must be less than omega C1. This is a condition. And omega F will be must be greater than omega C2. This is a condition. Omega I is, you have to consider, is which is less than the lowest corner frequency. Lowest, if there is another one, let's say omega C3 is there, but lowest corner frequency, highest corner frequency. So it must be less than the lowest corner frequency. It must be the higher than the highest corner frequency. This is the way you have to consider. Now, I'm asking you, Mr. X, Rokon Jaman, can you tell me any value here, omega I is what? Can I write here as a 5 radian per second, Rokon Jaman? Hey, Rokon.
Yes, sir.
Can I write 5 omega I? Yes, sir. You said yes, sir, right? Omega I must be less than omega C1. Omega C1 is 1 radian. It must be less than 1 radian
No,
per
sir.
second.
No, sir.
Then why
No,
you
sir.
cannot get it? Tell me any value.
It's 0.5.
Good, 0.5 can be acceptable. But in general, you can see in future, normally it is better to consider 0.1, not 0, but it must be more than that, but 0.5, 0.1, 0.2 like that. As a best is 0.1. Actually, most of the places, it is considered 0.1 radian per second. Good, I think you understand it. Now, let's go with another guy. Anybody? Sumaya Majid Swal. Sumaya, I think you can answer, I hope. What should be any value? Can you just tell me for omega F, any value? Maybe can right here 1.5 can be.
Yes, sir.
You should
Oh,
see it.
no, sir. No,
See
sir. No,
yourself.
sir.
Then what is
No,
your
sir.
Okay, tell me what is the answer.
Sir, 3.
3. Very miser. Very, miser. Why 3? Is very close to 2. Okay, normally you'll understand it when you get the graph paper in front of you, the log, semi-log graph paper. Then you understand what should be the reasonable value you should consider here. 3 is definitely okay because it's more than 2. But what reasonable value should be, you can understand it when you see the graph paper. But for your information, I can give you a good value here for the 5 radian, 50 radian per second, because you'll come to know later why. So 3 is okay, your answer is correct. But when you see the graph paper, then you can understand, no, 3 is very, very close to 2. It should be a little bit bigger, like that way.
Okay, sir.
Okay, fine, no problem. Everybody understood. These are the 4 points. Actually, you have to calculate for dB and degree. Whereas the equation is, this is for dB, this is the equation for degree. Get a snapshot. Your job now to calculate all these points. Who can do it fast, get a bonus point. Go and fast and raise your hand if you have done. Get faster. 2
Sir,
minutes time.
can I see the LM equation?
Okay, LM equation, I'm showing it again. Just get a snapshot. This is the LM equation.
Sir, I have taken.
Yeah, okay, go for it. Go for it. All of you can take the snapshot and then go. You have to consider only 4 frequency, 0.1, 1, 2, and 50, and do this 4 calculation.
Sir, I am done.
Sir, I'm also done.
Okay, can you tell me who said that I have done? What's the name?
Yes, sir.
First,
Mahmoud
first guy.
Kabir. Yes, sir.
First is Mahmoudul Kabir, and the second guy,
Atikur Rahman.
Atikur Rahman, Mahmoudul Kabir. Okay, so first let's see. And any other people? Another one I want to pick. No, only two guys had done it. Now let's come back and check it. Anyone to give this name? No. Okay, Mahmoudul Kabir, can you start telling me the answer? And all of you check the answer is correct or not. Mahmoudul Kabir, dB, go for the answer. What is the value for dB and degree? For 0.1, what is the dB?
So 19.94 and angle is minus 98.
Just a minute. Okay, 19.94. Can you see the screen?
Yes, sir.
Yes, sir.
Hey,
Yes, sir.
Okay. Okay, 94.
Sir,
And then what
I
is
got
the degree?
minus 10.09.
Okay, come on.
Minus 90.
Mahmoudul Kabir. It is minus 19 or 19.94?
Minus 19.94 and angle is minus 98.
98 degree. Okay. What is the next one? Omega C1, 1 radian per second.
Minus
What's the next one?
3.97 and angle is, sir, for
97
omega
degree.
minus 3.97 and minus 161.
161. I think I'm writing, you can see. So omega 2.
Minus
Omega C2.
16.02. Yes, sir. Minus 16.02.
16.02 dB. Then what is the angle?
Minus 198. 198.
98. Good. Then what is the
Yes,
next
sir.
one?
And then
50?
minus 95.92.
95. Okay.
Point
dB.
92.
And what is, okay, 92.
Minus 266. 266.
66 dB, a degree.
Yes, sir.
66 degree. Okay. Okay. Now another guy who said, second guy. Hey, who is the Atikur Rahman? Okay. Where is the error you
Yes,
said?
sir.
Which one?
Sir, I have not similar values with dB. But
All
same
the dB
values
are
of
different.
degree
All
is
the
same
dB are
value
different. Come
sometimes.
on.
Yeah.
Your dBs all are different.
Yes, yes.
Okay. First one. What is
Yes.
that? First one.
Minus 10.09.
Minus 10.09.
Minus
Okay.
10.09.
Then next one.
Minus 16.02.
Minus second one. Second one.
16.02.
For omega is equal to 1.
Yes.
Okay. Then omega is equal to 2 is what?
Minus 22.64.
22.64. Good. Then what is the
Minus
third one?
77.38.
77.38. This is
Yes,
22. And angular same.
Angular same.
Okay, fine. Excellent. Now I'm talking to rest of you. Yes, who is that?
Sir, Sumaya.
Okay, Sumaya, what is your answer?
Sir, my answer for DBs are the black ones.
And angle?
Values written. Angle are same.
So you follow the first guy.
Yes, sir.
Okay, now any other people done it or all are having the lollipop?
Also black ones.
You're one. Who are you?
Alamin Patori.
So you have to tell. We don't know. He's a prime minister of Bangladesh, right? Alamin Patori also got the same answer. Good. And I think 3 of you got the same answer and the black answer, right?
Yes, sir.
Yes,
All right. Good. So I think we don't need to waste time. All of you can copy paste the black
I
answer.
also got the black one. These
Yeah,
are
good.
all should be.
I think that should be fine. You can verify your answer with the black one, those who got. And Atikur Rahman, you just check the answer you got.
I think I have written the wrong equation. If
Wrong
everyone
answer.
has,
So I think that should be fine because you are scared. Everybody got black answer. How come I can defend, right?
yes, sir.
And you found this, so you made a mistake, really?
Yes, sir.
Okay, good. In that case, this is excellent. So I hope that all of you got the answer like this, or got it not, please copy the answer. That is what all of you do it, and later on you can check whether answer is correct or not. Now things are done. All what we have jumped to the semi-log graph paper. Everybody now get the semilog graph paper in front of you. All of you, please take the semilog graph paper in front of you, because we are now going to draw it on the semilog graph paper. Okay, can you see the screen?
Yes, sir.
Okay, all of you, please keep your semilog graph paper in front of you in this way. In this way means so that this is 0, this is 1, 2, 3, 4, like that, and the logarithmic axis 1, 2, 3, 4, the horizontal, so that the highest one 1000 will be at the right corner. 0 and 1 should be in the left corner, 0 and 1. Okay, just keep the semilog graph paper in front of you in this way. And after that, you can see this is called semilog graph paper because there are two axes, y-axis, x-axis, and y-axis. X-axis is graduated in the x-axis is actually in the logarithmic axis, which is log axis we call, and y-axis is the normal axis. This is normal axis and this is log axis. So semilog, if this is log axis and that is log axis, that is called log-log graph paper. Log-log graph paper is the x-axis also log, y-axis log-log. That can be used for telecommunication antenna design. You can see the Smith chart propagation there. The log-log graph paper is used to define the antenna length, and all these calculations use that log-log graph paper. But here we need the semilog, one log and one normal. That's why it is called semilog graph paper. Okay, so I think you all got the thing. Now in our case, the log axis, that is the x-axis, we are the x-axis, we will go for this as a frequency omega, and this one we are going for the dB, and we are going for the degree. So that means we are going to divide the graph paper in the middle, and upper half we are going to use for the dB versus omega, and the lower half we are going to use for degree versus omega. This is the way we are going to draw both graph, and that is called Bode plot. So that one we are going to go for afterward. So we are I'm going to tell you how to do it. This is the main reason why it is called semilog, and how we are going to draw both graph. Let us go for it. Now, the frequency axis, the x-axis actually the minimum value is 1. You can see here the frequency omega is 1 and maximum is 1000. So 1 and 1000. Just 1 minute, please. I have a call. Hello, assalamu alaikum. Alaikum assalam. আচ্ছা আপনি আমি একটু মিটিং এ আছি একটু মানে কতক্ষণ পরে আসতে পারবেন না আমি এখন আপনি এখন আসতে হবে না আপনি একটু পরে আসতে হবে আপনি যখন খুশি তখন আসতে হবে না আমাকে ফোন করে আপনাকে অ্যাপয়েন্টমেন্ট করে আসতে হবে আমি এখন মিটিং এ আছি বলতেছি তারপর আপনি জোরাজুরি করছেন কেন আপনি দুটো না আমি শুনেন এখন কথা বলতে পারবো না আপনি 2:30টার সময় আসেন ঠিক আছে হ্যাঁ সরি 2:30টার সময় আসেন হ্যাঁ হ্যাঁ hello I'm sorry can you hear me
Yes, sir.
Yes,
okay
sir.
I'm sorry for that okay one is the minimum and maximum is 1000 but our frequency minimum is 0.1 maximum we can say like 500 or some 550 or something like that so minimum is 0.1 but here minimum is 1 so it cannot be drawn from here so better we can do one thing if we multiply the x-axis by 0.1 the whole multiplication then 1 will be what 1 will be this 1 will be 0.1 and that 100 the 1000 will be 100 right this is starting will be 0.1 this is starting will be 0.1 and that final value will be 100 do you understand it if we multiply the x-axis by 0.1
Yes, sir.
okay good so this will be 0.2 this will be 0.3 and this will be ultimately 1 then this will be 2 this will be 10
Yes, sir.
and this will be 100 that's the way we are going to do so you multiply it 0.1 just write it on the top of the graph paper this multiplication of 0.1 all right and y-axis you don't need to do anything y-axis is as it is but we can define the y-axis divide into middle and then upper part we can go for it and then we say the top point is 0 so we can say this is 0 dB then it is 1 and like that way now if you go to the dB side is what positive we have positive 20 dB approximately then negative 0 is coming then negative 90.5 95 point something so we are having some problem here that it is plus 20 so our one is started from 0 so we cannot put 0 here rather we can do what according to our requirement we can say this is 20 dB this is 20 dB means plus 20 dB then this will be we can say 0 dB then we can say this is minus 20 dB then we can say this is minus 40 dB right minus 40 dB then we can say this is minus 60 minus 80 and minus 100 if this is the way we can 95 will be in between so in that case 0 dB line will be the baseline and this 0 dB line will be this one we can draw the 0 dB line like this this is 0 dB line so your 0 dB will be here 0 dB line is drawn in this way this is what our first thing we are going to do for the log magnitude curve and then now if you go and draw it then you can take the first point the first point is what the first point is your we can say that first point is for omega equal to this it is 20 dB almost 19.94 is plus 20 dB so 0.1 and 20 dB so 0.1 is this line and 20 dB is line so if I ask you where is the point every children should know that the point will be here right the corner point you understand or not
Yes, sir.
Yes, sir.
all of you try to get it because this is important to know Okay. Then go to the next point. The next point is 1 and minus 4. 3.97 is almost approximately 4. So 1 minus 4, 1 is here. This is one frequency line. 1. 1. This is 0.1. This is 1. Okay. 0.5 is a 4. Minus 4 is, this is 0 dB. So each point will be 2. 2 means 1, 2. So this is here. You can just check. This is the point approximately. Isn't it? Yeah, approximately. You can just think a little bit up maybe. This is the intersection point because this is minus 4. 0 point minus 4 dB. I'm talking about intersection, that point. Hey, all of you got it, the point?
Yes, sir.
If you understand, you draw on your graph paper and then you come back to me that yes, I have drawn. This is very important. Plasma, one bonus point, remind me at the end. The guy who got bonus point, remind me at the end. If you understand, then you can go for the other 2 points. Can you draw? Then I'll show. Draw omega equal to 2 and 50. 2 and 50 line, I think you have to draw like this. This is 2. Okay, and then 50 is here. If you go 400, 500, this is 50 line, remember. Okay, this is your 50 radian per second. So these lines are, you can get, now only the dB you have to go and draw. What will be the dB? You can find it by yourself. Please draw the other 2 points by yourself a bit faster. When drawn, then tell me, I'll draw and check. Okay, done. Then you check it. 16 will be here. Approximately this is the point for 16. Then 95.9 is 95, 96. Yeah, 95, 96 is somewhere here. So you can go. Somewhere here. It is the point of intersection between these two. So you got it. Now these are the 4 points we have approximately. These 4 points for those 4 omega. I think everybody check your points approximately like this. And then what you have to do, you take a ruler or a scale and draw the straight line. Join the points with a scale or any straight bar or something like that. Draw the line like this. Let's say for the first 2 points, you draw with the scale. I'm talking about this guard. You draw with the scale straight away with a scale, and then you can just extend the point dotted line, extend it by the dotted line. After the frequency second point, you just dotted line, it just dot line. You can see the dotted line from there. Then you join the next 2 point. Next 2 point will be coming like this with a scale. It will be a little bit inclined down, and also that one you have to dot the dotted line. Extension can be straight line. It will be straight line. So you can just go ahead in that way. Now you can go ahead with this, and this is the red one, extend it in that way, and after that the last 2 points, through that you can draw the straight line with a black straight line. Okay, straight away you join the 2 points. Straight away just draw the 2 point. Okay, like this. Then you complete the 3 points. 3 segment of straight line are there. One is a blue segment between the 2 point straight line, then the red segment between the next 2 point 1 and 2, then the black line is straight away up to the last infinity. So there are 3, these are called 3 asymptotic curves. 3 asymptotic curves you have to plot, and you can see the dotted line. If you omit the dotted line, forget about the dotted line, only the rigid line you can get. This is called log magnitude curve. This is your, okay, I'm writing it here. This is your log magnitude curve. This is your LM curve, the rigid line. So there are 3 segments of this asymptotic curve. First asymptote, second asymptote, red one, then the black one. And their rigid lines are log magnitude curve, called log magnitude curve. Now, if I can divide it in this way, the blue one, if I say blue one is for what equation, the blue curve along with the dotted line is coming for the first part of the equation. You go then s by 2, s equal to s by 2, I mean 2 by s, 2 by s giving you the first one. There is 2 by s, 2 by s, the first part, and up to what, this line is coming up to the first corner frequency. This is your omega c1, this is your omega c2, right? So from the beginning up to the first corner frequency, it is 2 by s, because first corner frequency is omega c1, so up to that. And from the first corner frequency, which is coming from s plus 1, from the first corner frequency, the next curve will be, I'm talking about this one, the red one. What will be the red segment I'm talking about? Red curve will be from the first corner frequency. What is the thing included? We have to look into that. If you go, it is first corner frequency is coming from this. So along with this together, these 3, 2 by s and s plus 1, these 3 are representing, or these 3 are contributing this red curve, which is 2 by s into s plus 1. S plus 1 is coming from the first corner frequency, remember, and that's why the red line is having the s plus 1 with it on top of 2 by s. The red curve means this up to the dotted line. All the equation for the whole dotted red curve is 2 by s into s plus 1. And the black one coming, the black one is coming after the second corner frequency, omega c2. And the second corner frequency is coming from where? It's coming from the s plus 2. It is combining together, the whole guard together is giving you 2 by s plus 1, s into s plus 1, s plus 2. So the black one is coming from all the things 2 divided by s into s plus 1 and the second corner frequency where it starts from the previous one plus the additional second corner frequency, which is omega c2 coming from s plus 2. So that's the black curve, and it goes up to infinity. So there is no end. It will go through the 50 and it's go to up to infinity. So these are the 3 segments of this curve, and in the blue segment equation will be 2 by s. This blue segment is same 2 by s. The red segment, this one I'm just talking about, is what? 2 by s into s plus 1. And the black one, as I have already told you, the black one is the whole thing is going on with the same. So these are the 3 equations for these 3 asymptotic curves, and every corner frequencies it is bending, and the final curve is coming with the blue, red, and black combination is giving you the log magnitude curve. That is your final log magnitude curve we are having here. Is it okay? Could you draw?
Yes, sir.
All of you understood how to draw it?
Yes, sir.
Good. Now, if you understand it, now we have to do some sort of analysis on it. The slope we have to calculate first. If we want to find the slope, you are very much familiar how to find the slope. Slope is very much simple, and you know that can be like this, right? Dy by dx, or straight line slope. If you know the 2 points, then you can find the delta y by delta x is difference between these 2 points. Like one point is x1 y1, another point is x2 y2. I think you are very much familiar with this. One point is x1 y1, another point is x2 y2, and the slope is what? If I say what is the slope, you have studied in A level HSC that y2 minus y1 divided by x2 minus x1. Remember? Hey.
Yes, sir.
Okay, exactly the same thing we are going to apply here. If we want to apply here the slope definition, first of all, we have to see what is the point. What is the point here? What is the point at this, what is the value of this point? Tell me first. It is what? The y value is, x value is 0.1. 0.1. And y value is what? 20, right? 0.1, comma, this is 20 dB. Isn't the point? You got my point? 0. Okay. Then what will be this point? This point will be what? Can you tell me?
Minus 4.
1 angle, and what is the value? Minus 4. Good. Minus 3.95 or something like that, dB. Hey, rest of you understand what we are talking?
Yes, sir.
Okay. If you understand, then you can imagine these 2 values are like x1, y1, x2, y2. But this is the scenario, and I ask you what is the slope? Then you should tell me slope is y2 minus y1, x2 minus x1. That formula, if you apply, then what will be the slope coming here? Can you tell me what will be the slope coming here? What minus what?
Minus 3.97.
3.95 or 4 minus 4. Okay, 3.9 minus?
Minus 19.9.
Okay,
19.9.
I'm writing here slope equal to, you said minus 3.95 or 4 minus 19.
Minus 19.
Minus 19.95, right?
Yes, sir.
It's okay.
1 minus log 0.1.
Okay, minus 19.95 divided by 1 minus 0.1.
log 1
1. Yes.
minus log 0.1.
Good. That is the answer. Log 1 minus log 0.1. Remember, this is the answer, not 1 minus 1, because this is x-axis is not the normal axis. X-axis is the log axis. So it will be log 1 minus log 0.1. On the top is what? Normal axis, dB. So if you do the calculation here, then what you get here is your minus 24 or 23.9, whatever, or 24, is it? Okay.
23.9.
Something like that. I can just write it 23.9 divided by what? Log 1 minus log 0.1, right? So log 1, log
Yes,
1,
sir.
log A minus log B. If we log A minus log B, then what is the log? Hey, log A minus log B is what? Log
A by B.
A by B. Log A by B means log 1 by 0.1, right? Yes? Okay, if it is something like that, then what we get here is log 1 by 0.1 means we can say 10, isn't it? 1 by 0.1 is 10, right?
1.
Hey, 1 or 10? What,
Yes,
1 or 10?
10.
Should I
Yes,
write
10.
1 here?
Oh,
Why you
Also
said 1? Why you said 1, right? Okay, this is 10. Now, log means the base 10. Base is 10, right? It is not natural log. Log means base 10. Base 10, 10. And this is 29. 23.9 is what? dB. And this is 10, 10. So log 10, 10 by definition is 1 decade. This is decade, base 10. This is not octave, decade. So octave 9, 7, decade, like that way. The decade definition is log 10 base 10 is 1 decade. So if that is the case, then what we are going to get here is a minus 23.9 dB per decade we are getting. Minus 23.9 dB per decade will be the slope of this blue line. The blue line slope is, we can get minus 20, approximately standard case. This is a very exact case, but approximately asymptotic curves is giving like 3 dB below. Actually, the corner frequency point should be in real curve. It will be 3 dB below the original point. So it is asymptotic, that's why it is the value. When you go to the real curve, it will 3 dB below means it approximately 20 dB per decade is a standard form. So 20 dB per decade will be the standard slope for the blue curve in real case. And then we can say that this is gone, this is gone. We can say that this is your 20 dB per decade curve. Okay, so you can write that this duck is minus, approximately minus 20 dB per decade as a in standard, 20 dB per decade. And this is how the calculation is done. Okay, now if you go like that and do the calculation like that, then the red curve will be coming, and the 20 dB per decade is coming for this S. Remember, this S is giving you this slope minus 20 dB per decade, one pole at S equal to 0 at the center, one pole giving you minus 20 dB per decade. And if there are two pole S square, then it will be minus 40 dB per decade. And if it is S cube, then it will be minus 60 dB per decade, like that. Means, hey, what is the type of the system here? In our case, type. Remember the type?
1.
type 1.
Type 1 system gives you minus 20 dB per decade, because type 1 is having only one S. Now, if it is a type 2 system, it should start with minus 40 dB per decade. And a type 3 system, it will be minus 60 dB per decade. That's the way actually it works. Now, if you go for the red curve, then another 20 dB is coming from S plus 1. This is another pole. Poles are giving negative 20 dB per decade, each of the pole. And each of the zeros are giving positive 20 dB per decade. Remember, this is the thing happened. If there is a 0 there, it will give you plus 20 dB per decade. Like I'm just going to do here, you can understand it. Okay, 1 plus T1S, as I show you, T2S and S into S plus 1 plus T3S. Like that way I have drawn like that, T4S. But this is giving you plus 20 dB per decade. Like that, this is another 20 dB. And this is giving you minus 20 dB. This is giving you another minus 20 dB. Another minus 20. So each of the pole gives you minus 20 dB per decade. Each of the zeros gives you plus 20 dB per decade. If that is the way we go, then your red curve is adding another minus 20 dB. So the red part of the curve, I mean this one, what will be the slope of the red curve? Will be minus 20, another minus 20. What is that? Minus 40 dB per decade will be this one. That is the slope for this one. And similarly, the black one, if I ask you, open question, what will be the slope from that point of view? What will be the slope of the black one? Can you tell me? Minus what? Anyone?
Minus 60 dB per decade.
Absolutely correct. I think everybody understood it, because black one is S plus 1, S plus 2. That means each of them 20, 20, 20, minus 20, minus 20, minus 20. It will be minus 60 dB per decade. If you calculate, you get something like that, approximately. So this is the way you have to understand the thing. Now, for that curve, if I go for it, then it can be like this. Minus 20, then the first corner frequency comes, maybe 0. It is 0, 20. The second corner frequency, if it is, let's say, another 0, then it will go up. But if it is from the pole, then it will go down, like that. And again, another 0 coming and another 0 coming, like that. Because I have written T1, T2, T3. Let's say this is smaller, then this is bigger, then bigger, bigger. I'm assuming like that. T1 is more than T2, more than T3, then T4, like that. I'm talking the other way around. Okay, then it is like this. Minus 20 dB is coming first from the S. Then it is 0, means coming from 1 plus T1 S divided by S, like that. So it is 0 dB, because minus 20 minus 20 cancel, 0 dB per decade. Then plus 20 dB, this one. Again, minus 20, 0, again, minus 20. Like that way it will go. So I think you can understand it when it comes to certain point. So far, this is the way you have to find the slope of the line of the asymptotic curve. Are you okay, or you are having some question? What? Anybody got any question or understand it? Yep. Hey, do you understand it?
Sir, can we just write down minus 60, or we need to show the calculation?
No. Just write down. That's why I'm talking about. First of all, to show you. Just I'm telling you an example, then it will be much more clear. For example, GS is, I'm giving you 10 into 1 plus, let's say omega, S plus, like that, S plus 1. Then I'm writing here S square, S plus 2, S plus 3, like that. Then I'm asking you, can you tell me what will be this thing? The first thing is what? First thing will be S squared. So straight away it will give you this thing. What will be the slope for the first, up to the first?
Minus 40.
Excellent. That is the answer. Minus 40 dB per decade. This is omega equal to 1, remember, right? Up to the first corner frequency. After the first corner frequency coming from here. Okay, now you tell me. Next one will be up to the second corner frequency is 2. Then the third corner frequency is 3. So from here to 2, it will go down or up? Or which way it should go? Because minus 40 is coming from S squared. Then it is giving you another what? Plus or minus? Plus 20 dB per decade. Now the curve should go where? Straight, little bit upward, or downward, or that one. So 1, 2, 3, 4. Which one? You're short
It
circuited.
will go downward.
I'm talking about 1, 2, 3, 4.
Three.
What do you mean by it?
3.
3. Okay, if it is 3, then what will be the slope?
Minus 60.
Okay, minus 60. Do all of you agree?
Yes, sir.
Okay. This is minus 40 and you are adding a plus 20 dB with this, right? So omega 1 is coming from this. If minus 40 is adding with plus 20, will it be minus 60?
No, sir.
Minus 20 dB per decade.
Minus 20 dB.
Then what you are talking, you don't get it. Okay, it is minus 20 dB per decade. That is the reason why I have drawn that way. 1, 2, 3. Minus 60 is a number 4, and this is 1 is a 0 dB per decade. So it will not be 0 even. So it should be like that. Now it's a little bit inclined, but it's not going straight, but it's a little bit up. So minus 40, this will be minus 20. 1 plus 20 up, like that, up to the 3 corner figures. After 3, then x plus 2 is coming, because 2 it's a pole. It's giving you what? Minus 20 dB. This is giving you another minus 20 dB, right? So from 3 to next point, from this point to that point, it will go what? Straight down, up. Two is coming from the 0, which is minus 20. So you are adding a minus 20. So it should go what?
So downwards.
Okay, downward. If it is downward, then what will be the if downward, and what will be the thing? Oh,
Minus 40.
minus 40. Good. Minus 40. And here minus 40. Okay. So it is minus 40. Like that way you have to go. And after that another minus 20 coming. So it will be minus 60. After that it will be minus 60. Right?
Yes, sir.
Yes, sir.
So this is the way actually you have to go for it. I think next class I'll explain these things more clearly, then it could be fine. So far you can do the analysis at home, and next class we are going to draw the phase angle curve underneath over here, over this point, and then from these two we are getting the total Bode plot, and after the Bode plot we are going to determine different parameters from the Bode plot. So next class is very important. And so far, what we have drawn up to this, everybody must bring the graph paper with you in the next class. And this is all in all about the Bode plot. Half of the Bode plot is done. Half of the Bode plot means, I told you, Bode plot means two things. One is your log magnitude curve, another one is a phase angle curve. And log magnitude curve we have already drawn. LM curve. Now next class we are going to do the phase angle curve. Once we've done the phase angle curve, then our complete Bode diagram is done. After that we'll do the rest of the part. It's very simple because only 4 points you have calculated for this problem. Like that 3 to 4.5 points you have to calculate for Bode plot. Once you understand, it will be very simple for you to answer to this question. I hope that so far so good. You understood it up to this?
Yes, yes, sir.
Yes,
Okay.
sir.
Okay, fine.
Yes, sir.
Next class, we'll do the rest, and then we have to go for some sort of problems to solve, and you will understand it much more clear, because Bode plot is very important. We are going to do some of the problems on it, and then we are going to jump after finishing Bode plot. I think with 2 to 3 or 2 more classes I think will be required for the Bode plot, and after that we are jumping to the root locus and controller. PID control and these things. So I think that should be the way we can go. If you have no question, then fine. It is officially, I'm going to stop the class.
Okay, sir.
Yep. Thank you very much.
Excuse me, sir.
Yes,
Sir.
go ahead.
Sir, I have sent